is really quite interesting. When we draw out the skeleton, we have a 3-carbon chain, 2 hydrogens on each end, and so right away we see none of the carbons have a filled octet. They all need 4 bonds. So the way we can achieve that is to make this a double bond and make this a double bond. Okay, so we have 2 double bonds on top of each other sharing the same carbon. This is called accumulated double bond. This molecule is actually called allene. So you can look that up and see some examples of that. The hybridization of these N carbons with 1, 2, 3 regions of electron density is sp2. These N carbons are sp2, and this middle carbon is sp hybridized. It has just 2 groups, so it's sp. So what's interesting about allene is most of the sp hybridized carbons we've seen have been triple bonds. This is an example where we have 2 double bonds, and we'll see what that does to the geometry. Okay, so let's start with our first carbon here. sp2 is trigonal planar, so we could draw that very nice in the plane, like so. Put our carbon here, and hydrogen, hydrogen. And where does our pi bond go? If we've drawn the trigonal planar in the page, then our p orbital is out here, perpendicular. And we can overlap them to form the pi bond. Okay, and then this carbon is sp hybridized. Sp means linear, so we can draw this straight out this way. But now, when we think about how to form this second pi bond, it's going to be another p orbital. Where is the second p orbital for sp hybridized? Sp hybridized atoms always have 2 unhybridized p orbitals. We've already shown the one that's in the x orbital, in the z orbital, straight out and back. So where's the second one? It's actually in the y orbital. It's in the y-axis, perpendicular in the plane. So if we draw that on each carbon, we see that's where this second pi bond is. So it turns out for allene, when you have accumulated diene like this, the 2 pi bonds are orthogonal to each other. They're perpendicular to each other. Which means now when we draw these hydrogens, if the p orbital is in the plane, what does that do to those hydrogens? They can no longer be in the plane. They have to be perpendicular to that. So it turns out that one is a wedge and the other is a dash. So allene has a twisted geometry. It is no longer planar. These 2 hydrogens are in the plane, and the other 2 hydrogens are perpendicular. And that's because here's the p orbital that connects to this carbon is in this direction, and the p orbital that does a double bond on this side is in this direction. So this is called allene, and it has this twisted geometry, really interesting molecule when you consider the 3D sketch.